So an alloy is, the definition of an alloy given to you is, it is a homogeneous mixture containing at least one metal formed when liquid metals are added together and allowed to form a solid uniform composition. Example, iron and carbon, although it's usually the second one's also a metal. Okay, so you need to sort of be very good on saying why it's a mixture, because that's a big part of the syllabus. So there's a few points here. So number one, it is non-directional. The bonding is non-directional. And they're not in any set proportions. I've sort of repeated that, not in fixed proportions. You can separate them physically, which is a key part of a mixture, and they retain their individual characteristics, although overall you alter the overall properties of the mixture by doing different proportions in there. Okay, so you can see here I've sort of mixed it up here. Hopefully it looks fairly homogeneous. Okay, while we're on to that, I might just jump to the fact that you can actually make it heterogeneous by heating and cooling, creating these crystals. And so you can see that there are different parts to it. So there's an exception to that rule. Maybe we should just forget that because that's not part of your definition. Okay, so the main reason we mix two metals together is for strength and corrosion resistance. So the strength is pretty easy to understand because you can almost model this. If you get a slightly larger one there, you can no longer slide them across each other as easy. It sort of like buckles up and causes much greater resistance. And so that's why adding two metals together increases their strength. So obviously we want to increase strength because that's what we use metals for. They're still malleable. And the other main thing is probably not so obvious is corrosion resistance. And all it takes is a small amount. So for stainless steel, it's above 10%. I think it's 11.5 or something, but I'm just rounding off to 10. And so what normally happens with these cheap freely available metals like iron, which are everywhere, the problem with this iron is that it forms an oxide layer that still allows oxygen and water to get in and keep corroding until the whole thing's gone. And so the more expensive metals, we're not going to use gold and silver, but aluminium and chromium, the more expensive ones are less reactive, and they'll form an oxide layer that doesn't allow further interaction with oxygen with the unoxidized metal, so an alloy in there. And even if it's scratched, as long as it's of a certain percentage, that still forms, when it reacts, it still forms an impervious layer. It doesn't have to be 100% an actual physical chromium layer. Just 10% chromium will form a layer over the whole exposed surface. And so that's how that works. So that's why alloys are effective, because you only need a little tiny percent and it'll still form the protective layer. Okay, so corrosion resistance and increased strength. So they just want you to be aware of a few. They're not going to test you on that, it says in the syllabus. So as you can note, there's the chromium. There's the stuff that rusts really badly. Tin also is probably similar to this, so that copper isn't too bad, but it does go green. And so bronze is much more stronger in corrosion resistance. Zinc is very good at resistance, corrosion resistance too. And so you've got these various combinations. Usually one is cheaper and one is more expensive that gives the strength and corrosion resistance.